Well, good evening, and thank you those who have joined us this evening. We're happy to have a session on STEM. It's elementary, incorporating technology into the elementary classroom. And our speaker for this evening is Nancy Foote, who is a Casio on our Casio Teachers Advisory Committee, and she teaches in Gilbert, Arizona. And I am Nathan Austin, the Curriculum and Online Training Manager for Casio. So one just technical detail, those who have joined us this evening, we have you all on mute automatically just to keep a good standard of audio quality. If you have questions, you can type it in the question panel. It should look something like this. And one of our facilitators will respond back privately. Generally, that's me, but sometimes we have help. You can also raise your hand by clicking on the hand symbol in the upper left-hand corner of your attendee window. So in any case, like I said, we are very happy to have Nancy this evening. So without further ado, I will hand it over to Nancy.
Great. Thanks, Nathan. Hang on, let me make sure my screen is right and you can see what I need you to see. There we go. My name is Nancy Foote. I have been teaching for a long time. I think it's like 24, 25 years. It's been a while. This time of year, if you're like me, things are squirrely, right? I mean, kids are ready for the end of the school year. We actually only have about, who's counting, 7 days of school left, a week and a couple of days. So what I'd like to do tonight is go through a couple of things that you can use in a lot of different ways. One way, of course, we're trying to incorporate technology into our classrooms. We're trying to get, science and math embedded. We've got the Common Core staring us in the face. But what's really important also is that we don't waste any time at the end of the year. It's really easy to let these last days slip away, and we lose so much valuable time when we don't take advantage of every single minute. So I'm going to give you some techniques and some activities that you can do with your kids. You actually can do in your class tomorrow. Your principal will be impressed, you'll be impressed, and your kids will get some good quality learning out of it. So with that, let's go ahead and begin. The name of my presentation is STEM, it's elementary. And we're talking specifically about maybe grades 3 through 7, although you certainly can adapt what I'm going to tell you for lower grades and also for higher grades as well. So let's talk about the Common Core. Common Core math standards and next generation science standards. Whether you're a Common Core state or not, you're going to find some things that that are in common, pardon the pun. Basically, Common Core standards ask for several things. They ask for the kids to be flexible and adaptable. So if you learn something in one specific area, you're supposed to be able to apply it in a totally different situation. They ask them to have fluency in vocabulary. Some of my kids still struggle with product and sum. They shouldn't, but they do. I'll say the product of 8 and 4, and they'll say, is that when you add? So Common Core asks for students to know the vocabulary and to be fluent. Just like you're fluent in English, they want you to be fluent in mathematics. Technology is supposed to be embedded in everything that we do. I've been struggling for the last couple of months trying to come up with a really good definition for technology, and I don't have one. I don't have one that I'm totally comfortable with that I think is perfect. So if you have one, please feel free to raise your hand and share with Nathan or send us an email, something like that, because frankly I'm curious as to what your definition of technology is. So how do I address these topics with kids? I don't want math to be boring and tedious. I have a hard time when parents come up to me or say to their child in front of me, oh, that's okay, I wasn't good at math, you'll be okay too. I want them to be excited about math. I want them to be delighted about math. I want them to look forward to coming to class every day and to be eager, and so I use novelty. Novelty is the one thing that works best for me. If the kids don't know exactly what to expect every day, it kind of puts them off balance, and that's a really good way to get them hooked on mathematics, and that's really one of my goals. In addition to mathematics, though I am talking about science and technology, although you'll probably hear me referring to the word math more often than I refer to the word science or engineering. So one of the things is we play all kinds of games. I invent games all the time. I don't always write them down. I need to get better at doing that. but I invent games all the time. Games are a really good way for kids to practice, especially their math fluency, but it's kind of painless. If I gave them a sheet with 40 addition problems, they would probably revolt. But if I give them a game that requires them to do the exact same quantity of math, but it's a game, they love it. Are there winners and losers? Sometimes. Do I give prizes? Well, I generally give 1 extra credit point. Kids will do anything for 1 extra credit point, but in the grand scheme of things, when I have 1,000 points a quarter, that one isn't going to make a difference one way or the other, but it provides a little bit of motivation. I do all kinds of activities. We're going to go through some of those activities today, but I do tons of different activities. I also do podcasting. We're going to talk in a few minutes a little bit about podcasting and how you may want to do podcasting with your own students. Lots of things have come out of it. It started out as a kind of a 5-minute filler for my kids, and I got a grant and I got these great iPods and I wasn't quite sure what to do with them, so we started podcasting. And it has been incredibly empowering for my students to have their podcasts hosted up on the web and to see at the end of 6 months or a year that their podcast has been downloaded 10 or 12,000 times by students and teachers all across the world. Very empowering for them. Does that get them hooked on the science and the math? Absolutely it does. It really, you have buy-in. In addition, it's a good PR move. Grandma on the East Coast can listen to her granddaughter do a podcast, and they think that's really cool, and it is. And projects. I use a lot of digital photography in what I do, and so we'll talk about projects at the very end, but those are basically the 4 things we're going to talk about tonight. Again, if you have a question, please raise your hand. There's a little button that has a little hand that raised, and then one of our moderators will address your questions. All right, so one of the things I hear a lot about is, should there be calculators in the elementary classroom? This is a time when kids need to learn their basic math skills, and giving them calculators, does that detract from that? Does that make that challenge more difficult? In Arizona, and I don't know about your states, but in Arizona, our students are not allowed to use calculators on any high-stakes state tests. Some states have a calculator section and a non-calculator section. We do not. For a long time, the feeling was if they can't use a calculator on the test, they shouldn't be using calculators. They can't use a pen on the test either, and that doesn't mean we keep pens out of their hands until they can use a pen. I think it's very valuable, and I thought long and hard about this, and I came up with a way to handle it, and I'd like to suggest that maybe you give it a try too. I have 2 kinds of days. One day is a pretty number day. Pretty number days, we do not use calculators at all. They say, you know, I use a shoe bag that you get at, you know, at Walmart or Target, and that's where the calculators stay. It's hanging up. I can see where all the calculators are. I know who's got what, but they stay in the shoe bag. Pretty number days, all numbers are easily manipulated mentally. So it's stuff they should be able to pretty much do in their heads. If they have to write it down, it's not going to take a lot to have them figure out the answer. 300 times 10. I like to get my kids used to multiplying things by 10 anyway, so this is a good way for them to multiply it mentally. 45,000 divided by 50s. I like to teach them about throwing away the zeros, you know, reducing that and making it, simplifying it. I can't get away from that, but simplifying it so that it's easy for them to handle and easy for them to manipulate mentally. 10.8 plus 7.2. I teach them to make groups of 10s or groups of 1. 0.8 plus 0.2 is 1, and then you just add from there. 4,000 minus 900. So basically, those are all pretty straightforward, easy to manipulate in your head. That's a great time for them to practice their basic math skills. Ugly number day, on the other hand, is completely different. The first thing they do on ugly number day is they grab a calculator as they walk into my classroom or when it's time to switch to math. All I tell them is it's ugly number day, and I don't have to say anything else. They all know it. They actually like ugly number day a lot because it means they can use the tool. And a calculator is a tool. I don't think anyone would expect a carpenter to frame a house without using a nail gun. It's a tool, and so are calculators. So on ugly number days, these are numbers that are more difficult to manipulate mentally. They're probably going to require a pencil and paper or a calculator, or maybe even both. but they're not easy to hold in their heads. Some examples: 317 times 13. Now there's lots of tricks and stuff you can teach them, but that's something that most people have to write down. Again, instead of 45,000 divided by 50, I mess it up a little. I make that number a little bit uglier. Same with the addition problem. I like this one because I want kids to realize that they have to line up those decimals and not line up everything to the right, as they tend to do when they're first learning decimals. And then I like them to check it using their tool, using their calculator. And there's another one that's not very pretty. And it works very, very well for me. Now the reason that I do this again is because I want them to practice their basic math facts, but I also want them to have a chance to use the tool and get used to using the tool. Because frankly, when they get to middle school and high school, they're going to use calculators. They're probably going to use graphing calculators, and I don't want it to be something that's intimidating or scary to them. On our state tests, most of the numbers are pretty numbers. It's rare that you will find a problem on our state tests that does not have pretty numbers. In fact, I often tell my upper grade kids that on their state tests they can use pi as 3, and I know that's not a really good thing for them to get used to, but when they can't use a calculator, if you use 3 in Arizona, most of the answers are close enough. Now I don't know what's going to happen with our new Common Core test. We'll have to see, but I still believe that Pretty Number Day and Ugly Number Day is a very, very effective way of addressing your principal or your parents or your coworkers or even your own concern about, are using calculators in the classroom a good idea? So let's talk a little bit about random number math. I play tons and tons of games, random number math games, but the first thing I want to do is I want to show you how to generate a random number using a calculator. I've chose to use the FX55 Plus calculator. This is one of Casio's newest ones, one of my favorites. I like the green line. Those are all my fraction keys, pretty much. I like that it's bright colored. Kids aren't going to mind it. I did do a lot of work with double dice. The dice get lost. They make a lot of noise. By the end of the day, if you're like me, I see groups of kids come in constantly through the day, I probably have a headache. And what I found is this is a very easy way to take the mystique and the scariness maybe out of the tool. And we're going to generate a random number, but we're actually going to generate an integer. So to do that, I just hit Shift, and you see how this is in yellow? I'm going to hit that, and that just says do the yellow thing, don't do the purple thing. If I just hit this, it would tell me do the purple thing. Now if I was using a regular 6-sided double die, that would be, my integers would be between 1 and 6. So I want to say 1, and then I have to put a comma in. The comma is right up here. It's right above the pi sign, and it's also in yellow, which tells me I need to hit the Shift to get it. And there's my 6. Now, if I hit equal right now, a random number would be generated. I'm a purist. I like my kids to close their parentheses. You don't have to in this case, but I think it's a good habit to get into. So I'm going to generate a random number, 4, press it again, generate another random number. Some of the challenges that I had with double dice is that sometimes I want my kids to work with numbers higher than 6. So then I would buy a 10-sided double die. But on a 10-sided double die, there's a 0. And if I'm working with fractions, I don't ever want them to have a 0 in the denominator. So things got a little complicated for me. The other thing is I like to teach each kid at their level. I like to differentiate the experience and the problems for each kid. Well, maybe you have a gifted kid and you want them to generate a number between 1 and 12. That child can generate a number between 1 and 12. And maybe you have a child who's not mathematically as talented or is struggling a little more mathematically or has an IEP or a 504. And so maybe that person's numbers are between 1 and 5. This gives you the flexibility and the beauty of doing exactly what the kids need. Wherever they are, whatever they need, you can have it generate a random number. Let's take a real quick look at this random number right here. I have my calculator set on 3 decimal places. You can set it on a variety of different decimal places. I have 3, but this generates not necessarily a whole number. Now, it's very interesting to have every one of your students generate a random number, it's a decimal, and then ask the kids to get lined up in order. Or do 4 corners. If your number is greater than 0.25, go in this corner. If it's between 0.26 and 0.50, go in that corner, etc. You'll really get an idea on whether your kids understand decimals or not. So that's how you generate a random number, and I'm going to be referring back to that in just a minute, so I want to make sure you knew how to do that. All right, so now we know how to do that. Let's talk about some random number games. Again, my students will play these for hours. They get a little unhappy with me when I make them stop playing. They'll say, you know, oh, can we play more games? Can we play more games? I'm kind of tricking them into learning, but I'm okay with that. So here's the first one, Multiplication Rocks. I don't know if you've ever watched that Schoolhouse Rock. I'm a bit older than probably most of you, so I remember growing up watching that on Saturday morning, but this is my Multiplication Rocks. I'm going to have my students generate 2 random numbers. Now again, this is up to me to decide what range I want. I'm going to say the first number is the tens quantity and the second number that they generate is the ones quantity. You can do it however you want. You know, you can have them generate a bigger number. You can have them generate, it's up to you, whatever works for you, your kids. If I'm generating 2 numbers and the first number is the tens quantity, I'm going to want it to be between 1 and 9. That's just my personal thing. You may want to include zeros. You may want your tens quantity. You might want them to have 35 tens. And then they have to figure out what that is. So the flexibility is built in. So they're going to generate a 2-digit number. Then guess what? They're going to generate a second 2-digit number. Every student now has unique work. They have unique problems. You are differentiating instruction based on where they are and what they're able to do. Your mathematically gifted kids, their problems are going to look different than your gen ed kids, than your kids who are struggling. So next I wanted to multiply those 2 numbers together using the traditional algorithm. I use the word algorithm a lot in my class, and the reason that I do that is I see that it is on a lot of standardized tests. Now, standardized tests, the ones that my kids take, every question is worth the same amount of points, but they differ in the difficulty rating. What do the kids skip? Easy problems like this that have a word they're not comfortable with. So you'll see me use the word algorithm again and again and again. I want to get my kids used to that, the word algorithm. So I've seen lots of people do lots of different ways to multiply 2 numbers together. Something about a cop getting a donut, and I don't get that whole one, but I know how I learned, and I can multiply that way. What I like better, though, is the alternate algorithm. One of the alternate algorithms that I teach my kids is the matrix or lattice multiplication, and they love it. What I like about that is that once they learn that, they can use that all the way up through calculus and beyond. Any math that you have, you can use it. So when you're multiplying polynomials together, this works just as well. So now I've got the 2 numbers. They've multiplied it 2 ways. They've got their answers. Everybody's got a different answer. So if I go and try to check it right now, if I go and try to grade every single paper, it's going to be a nightmare for me. It's going to take me forever. So I let them check each other's. I usually say check your shoulder partner's work. If there's a disagreement, they check it with the tool. So they use the calculator. If they're working by themselves, once they get their answer, sometimes I just say go ahead and check it right away. Other times I've got to circle it or somehow acknowledge that yes, indeed, they did get the answer and they didn't just copy it from the tool. Okay? So random number fractions. This is where you have to be careful with your zeros. If you use a 10-sided double die or a die, it's 0 through 9. So there is a 0 on it. When you have 0 in the denominator, well, that presents a problem, right? Because we don't use 0 as a denominator for so many reasons. But from the time kids are little, 2nd, 3rd, 4th grade, they know the denominator can never be 0. So how do you get around that? I mean, do you just tell them, guess what? Today, if you get a 0 for your second number, you have to roll again. That's what I always did. Plus, some of those double dice or those dice are hard to read, especially when you get big ones. So now I use the tool. I say generate a random number between 1 and 9. The first number that you generate is the numerator. The second number is the denominator. That makes it really easy and clean for me. Now, depending on what we're working on, I choose, generate a second fraction. I forgot about that. So now you've got two fractions. Generally, I tell them if they get a number that can become 1, 9 over 9, 8 over 8, they can only do one of those. Otherwise, I have kids who try to just keep hitting that equal button until they get the numbers they want. So they've got two fractions. Based on what we're working on, we'll choose our operation. Now, sometimes I do it randomly. I have them generate a number from 1 to 4. I don't tell them in advance what it is. 1's addition, 2's subtraction, 3's multiplication, 4's division. It's up to them, you know. But meet the needs of your students. You know where you're at. You know what's going to work. And then they simply perform the math and check your shoulder partner's answers. Let me scoot back here. The beauty of this is that a fraction looks like a fraction, so let's go ahead and get rid of that. Oh, I didn't want to do that. Let's just get out of there. We'll get out of there. Okay, so a fraction looks like a fraction. So if the fraction I rolled was 2/5, I put in a 2, and just like math type, you have to tell it you're done putting in a number in the numerator, so you have to do this little arrow down, 2/5. And again, I have to tell it I'm done with the denominator. If I put a plus sign right here, the plus would go in the denominator. So I'm going to arrow over, and I'm going to say plus 7, 7/9. Oh, see? It fixed it for me. So it wasn't that messed up. Now I'm going to say equal, and that's my fraction. I have it set to give me improper fractions. You can have it set to do decimals. You can have it set to do mixed numbers. But that's the way I have it set. But isn't that beautiful? It looks just like what the kids would write. So it's very comfortable, takes the mystique right out of it. Okay, and I think most of this is going to go away when I reopen that. All right. Kids will play this for hours. They're very flexible with it. You can actually play kind of a war game where, you know how we used to have the cards and whoever had the higher card won? Well, now you can do whoever has a higher sum gets a point. Whoever has the sum closest to 1 gets a point. Whoever has the sum closest to 2/3 gets a point. Imagine you're in your last week of school like I am, almost my last week, and the kids are squirrely, and you're trying to get some good learning in. You want to take and use that time wisely. Spend a half an hour doing this. I mean, this is wonderful. This is a fun thing kids like. You don't want fractions? Guess what? You can do all kinds of stuff. You can do whatever you want based on your grade level and your student's ability level. So here's another game. I call it remnants. I call it remnants because of one thing. When I first met my husband's grandmother, I was shocked at the fact that she told me she never had leftovers. Her whole life she never had any leftovers. And she was like 80 at the time. And I was like, how could you live your whole life and never have leftovers? I thought it was pretty cool. I thought maybe I would want to try that. I thought it'd be kind of expensive, but whatever. Go over to her house one day for dinner, and I said, well, and I said to my husband, what are we having, for dinner at Grammy's? And he said, we're having remnants. Remnants. I mean, remnants to me was also always material, clothing, and cloth. And I said, what is that? And he said, it's leftovers. So in honor of her, I named this game Remnants. And you guessed it, we're going to deal with leftovers. Now I made a little chart, very easy to make. Depends on how much time I want to use on this game. This is probably a half an hour game for two kids playing against each other. You want to play a shorter game? Cut it in half. Even shorter than that, cut it in quarters. I put the numbers on. I put the numbers on based on what I wanted my students to be working on that day at that time. I laminate my cards. I laminate all my cards, and I would suggest that maybe you do the same if you're going to use them repeatedly. But also keep in mind that this is also another good way of differentiating instruction. So your kids know that their card is specifically for them, and it's based on their needs. Maybe you have kids that this is only 1 to 10. Maybe you have kids that this is not any prime numbers. Maybe you have kids that this is all prime numbers. You'll see what I mean in a minute. So here's the way you do it. Each player generates a random number. The player with the highest number starts first. For this game, I usually use 1 to 9, but it's up to you. Okay, whatever. They're going to generate another random number and divide the number on the game board by the number they generated. So we start here at 17. If they get, let's say they get an 8, 17 divided by 8 is 2 with one remainder. That means they'll move one spot. If instead they got a 7, 17 divided by 7, well, 14 times 7 is 2, so the remainder is 3. They'll move 3 spots. Does that make sense? Really fun. Kids really like this game a lot. They don't know what to do with remainders. They don't know how to find remainders. They don't know, sometimes we put decimals, sometimes you put fractions. What are they talking about? So this is a good conversation starter as well. Here's the trick to this game though. In order to win, you have to hit end exactly. So if you're right here, there's no way that you can win, right? I can't think of a number that you can divide by 35 by that's going to give you a remainder of 1. So if they're here and they roll or generate a random number and they don't get there exactly, they have to go backwards the number of spaces, and then they can keep going back and forth. Again, that's a rule that I made up. If you don't want to play that, and if you want to say whoever gets to the end first wins, that's fine. The flexibility and the beauty of this game is that you can do whatever works for you and your kids. It's A-okay. So let's look at one more aspect, and that's this little divided by R thing here, which I love. So if I had my 17 and I wanted to know what my remainder was, I could hit this, divided by 8, and that says tell me the remainder. The answer is 2 with a remainder of 1. The other option I used was 17 divided by 7. Oops, and I pressed the wrong one. Because I didn't press this, it's not going to say the R. So let's go back and do that one. 17 divided by 7, and I did it again. 17 divided by 7, that time it was right. And it tells you that I would move ahead 3 spaces. I'm trying to get myself and my students into the habit of using this key anytime they divide. And the reason I want them to get in the habit of doing that is because if you take a number and you see, I'm trying to get myself into the habit, and you take a number, you'll see that the remainder can be 0. So they still have a lot of information. All right, so let's go back onto this. You see how much fun your kids would have playing this? It's a good energizer. It's not the game you want to play when you want your kids to calm down and be quiet and relax. It's the game you want to play when you want your kids to be excited and invigorated and mentally stimulated. This is a good one for about 2 o'clock in the afternoon. After your kids have had lunch, they had their recess, they came in, they got their drink of water, they're all cooled off, and Arizona it's over 100 degrees already, so they're all cooled off, they're relaxed. Next thing you know, they're falling asleep. You want to get them awake and alert and moving a little bit. So this is a good game to do that. All right, Remnants Part 2. Guess what? Again, change it however you want. Multiply the number on the game board by a random number, and the number, move that number of spaces. It's in the ones place. So you can do it however you want, but this is the way that I do it, and my kids absolutely love it. Can't keep them away from it. In fact, I have found kids that will finish up some other work, and they go and get a game board, and they grab a calculator, and they start playing a game. And I am very supportive of that. I think that's absolutely wonderful. All right, 5-minute math. So you look at the clock. You have either 5 minutes before the bell's gonna ring and they're gonna go out to the bus or walk home or whatever they do, or 5 minutes till lunchtime. And you want to give them something to do, but you don't want to give them too much to do. And you don't want it to be very much of a hassle, and you know what I'm talking about. So here's what I came up with: the 3-digit locker number challenge. I have thousands of these, and I'll tell you how I got them in just a minute. First one, you're going to use your calculator to help you find a 3-digit locker number. Obviously, each of the digits is 0 to 9. So 3 digits, kids will say, well, what's the range of numbers? Well, the lowest could be 000, and the highest could be 999. So they have to use the clues. Challenge number 1. Now, the sum of the digits is less than 15 is a really important fact. The 3rd digit is 3 times the 1st digit is also a very important fact. The 2nd digit is 3 more than the 1st digit is also a very important fact. But at this point, I'm not positive I have a starting point yet. I'm not positive that I can logically figure this out. Fourth clue, the number is even, gives me some really good starting points. Now I have something to work with. One of the other beauties of these kind of challenges is that the kids need to realize that not always the first clue is the most important or the one that they should start with. We've gotten kids into the habit of going 1, 2, 3, 4. They go in order. When in this case, for me anyway, and maybe not for you, but for me, this was the most important clue. Now I knew the last number was a 0, a 2, a 4, a 6, or an 8. That doesn't sound like it cuts stuff down very much, but for me it really did. And that's how I was able to go ahead and figure out the problem. Next challenge. I'm not going to give you time to work on that because I know it's in the evening, last week of school, last month of school, everybody's a little tired. But I'm going to tell you something. You're going to come back to this. You're going to say, I got to figure that problem out. And you will. It's one of those kinds of things that kind of haunts you. Could your kids figure this out in 5 minutes? Depends on their age. This was written for maybe 5, 6, grades 5 and 6. But could you do the same thing with something that's written for grade 3? Absolutely. Here's my second challenge. Challenge number 2. The first digit is 2 more than the second digit. Okay, so now we're talking about some kind of addition, right? Okay. The second digit is 7 less than the third. That's kind of interesting, because what does that tell you about the second and third digit? Well, I'm guessing the second digit is probably not going to be 9 or 8, right? It gives you some good information. And the number is even. And this one only has 3 clues. They don't all have to have 4 clues. So where did I get my thousands of problems? I have the kids write them. If I have a student who figures this out in less than 5 minutes, then my challenge to that student is write your own challenge that we can work on. Now, I've been doing it for years, and so as kids walk out to lunch, it's their ticket out the door, whatever, they have to give me the answer to this, or they have to write their own. If you've got the answer, then you write your own. And it's been very, very effective. I will caution you, though, take a close look at the ones that kids write. They're not always correct. Any questions on that? I think everybody's doing okay so far. All right,
Yep.
let's move on.
No questions so far.
Are they doing okay? No questions so far?
Yeah, we're doing great.
Okay, beat the calculator. Love this one. Again, it's a tool. You know, and I tell kids it's a tool, not a toy, but you know, you play with it like a toy. You're going to, on your smartboard, on your whiteboard, if you still have an overhead, whatever you use, you're going to reveal a problem. I don't care what the problem is. It's based on your grade level. So make sure that it's, you know, grade appropriate. Reveal a problem. One student solves the problem using a calculator. The other solves it by hand. Pretty easy. If it was 3 plus 7, I would do that mentally faster than I could push the buttons on the tool. However, if you start with simple problems and increase the complexity, the kids will find that there is a point for them, which may not be the same point for other students, but for them, they're going to find when using the calculator is more efficient than doing the problem by hand. They will also find the point at which it is more correct. And this is really important because sometimes kids don't know that they don't know something, and so you need to make sure that that's obvious to them. Whether that's they take a quiz and they get the problem wrong, or they do a problem and they check it with the calculator and that's not correct. So this is a double kind of game. It puts one person against the other. It helps them get used to the tool. It helps them find the keys. If it was the leftovers, the remnants game, and you did it like this as a beat the calculator where everybody had the same number, I would have lost using the calculator because I kept forgetting to hit the divided by R. But it certainly will help your students, and it helps cement that relationship together. So again, that was another good 5-minute, you know, thing to do when you're waiting for the librarian to come and get your kids for specials or whatever. Divisibility rules, next game. Kids really, my kids struggled with this. Yeah, 5s and 10s, easy. 4s, no problems. Some of the other ones they had more trouble with, and then when you compound them, it gets even worse. So here's a challenge I gave to them. Use it should say use each number. Use each number 0 through 9 only once. Each one is going to be used only once to create two 5-digit numbers. That's pretty good. But each of those numbers has to be divisible by 3 and by 5. So now they have to do some thinking. How are they going to do that? How are they going to create two numbers that each one of them is divisible by 3 and 5? They'll work through it. Some kids it may take a while. Some kids may catch on right away. Using the calculator is very, very, very helpful in this. Eventually they will find patterns, but math is so much better for them when they discover the patterns instead of you discovering the patterns or you telling them the patterns. You have those kids, though, that are going to get this in a heartbeat, right? They're going to say, oh, I know what it is, blah, blah, blah. They're going to give it to you. So here's the challenge for them. Find the smallest 5-digit number that's divisible by 3 and 5, and then find the largest. And again, this is a problem, this is a game or a puzzle that they can make up their own challenges after that. Divisibility rules cannot, in my opinion, cannot be overtaught. So if I had 8th graders and I had 5 minutes left at the end of the class, I certainly would use these with my 8th graders. Very effective. All right, podcasting. One of my favorite things is podcasting. As I said, I got a grant. I got some iPods. Wasn't sure what to do with them. Also, I came across a little challenge. I would say 6 times 8. My kids didn't know it. I would say 13 minus 4, and I'd see them counting on their fingers. And I thought, there's got to be a way for them to get more flexible in their math thinking. They've got to be able to have coping strategies in, and how can I help that out? And I came up with this thing called mental math challenges. And I use conventional wisdom. By conventional wisdom, I mean the number of sides on a triangle, the number of stripes on the American flag, that kind of thing. That's what I use. When I had English language learner students, I didn't use conventional wisdom with them. For them to know what a 7 is really, it's in English, for some of them was very challenging. But if I said the number of days in a week, I would have lost them. So change this however you need to for your students. Differentiate this however your kids need to. But here's how it started out. I said start with the number of stars on the American flag. And I did have a student get up and start to count. I told her there were 50. And then I said add the number of stripes on the American flag. And I looked at my students and said there's 13. Divide by the number in a trio squared. Well, now think about all the things that you're doing. You're trying to hold that 50 and that 13 and that 63 all in your brain, and at the same time you're trying to figure out that a trio is 3 and squared is 9. Does square mean add or multiply? Or what does it mean? Oh yeah, it means 3 times 3, so that's 9. And then I got to take that 63 back and divide it by 9, and I'll come up with an answer, which is 7. And then I gave him clues as to the answer, and I said, the answer is an odd number. So far, so good. The answer is less than 10. Even better. The answer is the same as the number of days in a week. Did you get 7? You're correct. And we would do this over and over and over, but truth be told, I got tired of being the one coming up with the challenges. And so my students started coming up with challenges. Here were some of my rules. Oh, and that's one more thing. Are you faster with mental math or with a calculator? So again, beat the calculator. Have one kid use a calculator and another use just their mental math. Don't let them write it down. When I started, it was 3 operations. Now, we're a thinking map school, so flow maps work really well with this. But again, you can start with 2 operations or 10 operations, whatever works for you. 3 clues for an answer. This was really important. I had to teach my kids to take this big, huge group of every number in the universe and make it smaller and smaller and smaller until they got to their answer. So if I had an answer of 50 and I had a student that said, it's an even number. Well, that's good. That cuts it down into half. And then they said, it's the number of states in the United States. Well, then they've given away their answer. And so I had to teach them to make it smaller and smaller and smaller and kind of hone in on it. Very effective. I use conventional wisdom. Again, you can or don't have to. It's up to you. I found it was very interesting, though, what my kids knew and didn't know. So I'm going to let you listen to 2 of them. And then I'm going to talk to you about how these came about. These are 4th grade students.
Welcome to start with the number of weeks in a year. Divide by the number of wheels on a bicycle. Subtract the number in a duo.
Nancy, is there any way we could turn that volume up just a little bit? It's very quiet.
Sure.
Sorry.
That's right.
Divide by the number of sides on the average dice.
Is that better?
Yeah, that's a little better.
Your number is an even number. It is a perfect square. It is one digit. It is between 2 and 8. If your number is 4, you are right.
Okay, so let's talk a little bit about what just happened. My kids would write their mental math podcasts, and they would have to have it peer reviewed, just like we do. We have things peer reviewed. 2 of their peers would have to approve it, say yes, the math is right. They would come up to me and I'd give them a number. The reason I gave them a number is twofold. Number one is I want to protect their identity. I don't want anybody to know who it is. I feel really strongly about they have a right to privacy, but yet they should also be able to brag a little on what they've done. And if Grandma wanted to listen to that young lady's podcast, she would need to know she was number 266, because we had hundreds and hundreds of podcasts up there, and I don't want Grandma to have to listen to all of them just to find her granddaughters. So we came up with the numbering operation. It works really, really well. After they have their number, they literally just take the iPod, and it's just a nano, and they go out in the hallway and they record it. Now you could hear the door opening and closing. You could hear voices in the background. My other rule is one take, start to finish. So if you make a mistake, they knew how to delete it, and they had to re-record it. The reason for that is I wasn't going to be editing 25 or 30 mental math podcasts every night at home so that I could upload them. I wanted them to be done, correct, and upload them. I was more interested in the math and the technology than I was in the noises. After they recorded it, we would spend, as a class, usually we did this right before or after lunch, we would listen to 10 or 12 a day, and kids would give us a thumbs up, a thumbs down, or a thumb sideways. So yes, it's good. You should go ahead and put it on the web. There's a mistake on here that, or no, that you shouldn't because there's a mistake, or I'm not sure. They don't like the pacing maybe. They didn't understand some of the things. My kids got really into certain things. They got into average. They would say the number of arms on the average person. Well, technically it's probably not 2. I mean, I guess if you looked at a worldwide population, it's probably not 2. I couldn't seem to get them past that. So when they say average, that's what they're referring to. They said, well, some people only have 1 arm. Yes, but how many do you see with 3? I mean, I guess, so we had a little trouble with that, but that's something that we were able to overcome. But did you hear her talk about a perfect square? 4th grade, talking about a perfect square. That's amazing to me that kids got that cued into the vocab. Now, why don't you listen really carefully to this next one. This is one that actually got published. Probably shouldn't have. So here's another one.
Hello and welcome to Mental Math Puzzle number 273. Start with the number of stars on the American flag. Divide by the number of fingers the average person has. Multiply by the number of wheels on a car. Add the number of legs a dog has. Divide by the number of soda bottles you would have in a 6-pack. Your answer should be even. It is a perfect square. It's between 3 and 7. And your answer is a compatible number. Did you get 4? You're correct.
What a delightful, bright young lady, but I don't know what a compatible number is. And she meant composite. She said compatible, That's the kind of thing that you have to watch out for. She had written composite on her script. She just didn't say it. She said compatible. So, and unfortunately that's been downloaded like 6,000 times already. So with the mistake, maybe everybody's using it to show what not to do. I don't know. In any case, mental math challenges are very, very effective. One of the things that I found is when you have your calculator, you can check the math. The math isn't a problem. Keep in mind, though, this does not follow order of operations. So be very careful when you use your calculator, and be very careful when you write it down, because it does not follow order of operations. It is linear. It goes straight from clue 1 to clue 2 to or operation 1 to operation 2 to operation 3. Just want to give you that little caveat, because it came back and haunted me a little bit when I couldn't figure out what was wrong, but that's exactly what it is. So in terms of science, we now do an element of the day project where every day somebody else has to make a podcast where they describe an element, and the last clue they give is what the element is. We also do Where in the World Am I?, where they describe the climate and the culture. We've been trying to do the 50 states, so going to the different states in the United States. Also very effective. It really builds the kids' confidence. One of my students was in speech therapy, but yet he still wanted to do podcasting, which I applauded. I think that's fabulous. The difference in his speech from August to May was astonishing, and the fact that he had his podcasting meant that you could almost track it, which was really cool. So there you go, mental math challenges. All right, some of the projects that I do all kinds of projects. As I said, I take a lot of technology and incorporate it in my class. One of our standards, a 5th grade standard, was add a large column of numbers. How boring is that? Who wants to add a large column of numbers? Strapped a pedometer on each of my kids, told them the goal was 10,000 steps a day, and there we went. For most people, not for kids, but for most people, 2,000 steps is about 1 mile. Kids, it's probably to 2,500. Maybe their legs are a little bit shorter. That's okay. We counted it as 2,000 steps. So I would ask them, how many steps is it going to take to get from Phoenix to Philadelphia, to get from Phoenix to wherever we happen to be going? They would actually do the math and figure it out. They'd use their calculators, they'd use their tool, figure it out. I would have a pedometer on every kid. They were in tables of 6. The 6 people at that table had to find out how many steps they took as a group. The 6 of them added up together every day. There was always arguments. They always pulled out the tool and figured out who was right. Then, out of my 5 groups of 6, I have 5 more sets of numbers they now need to add together. Find out how many steps we as a class took in the last 24 hours. And then approximately how many miles was that? Got to be very interesting. We actually we had a big map of the United States. We walked across the United States, and we had a thing called Friends Day Wednesday. Every Wednesday, wherever we would end up being, we would find a school or a library or some educational institution, and we would call them up and we would talk to the teacher and the students at that class. What my kids don't know is I kind of anticipated where they would be on Tuesday, and I called the teacher or the school or the library and made arrangements the day before. But my kids didn't know that, and I would say, it's Friends Day Wednesday, where are we going to end up? There we are. Okay, who should we ask? Let's find the school. And it ended up being a really, really cool thing. So it incorporated technology and mathematics and science and probably a little engineering and social studies and talk about cross-curricular. It was fabulous. Kids loved it. So did I. All right, so, oh, I'm sorry. I should have also said how many days will it take. And how does this change? Could we walk to the moon? Could we walk around the earth? How long would it take us to get to China, assuming that you could walk across the ocean, that kind of thing? This is probably not a 5-minute activity, but man, I'm telling you, the kids loved it. And they would pace around my classroom if they weren't close to their 10,000 steps, because they didn't want to be the one to say they only got 4,000 steps the day before. They also brought their families into it, so it's been a win-win situation. It's a great way. You can get pedometers for $3 or $4, and I wrote a grant for it, so the money's out there. It's easy to get. Okay, scavenger hunts. Last thing I'm going to talk about are a couple of little scavenger hunts that I do with my kids. I take pictures, and then I ask questions. So check that out. If you live in Chicago, you know exactly where that is. I grew up in Chicago, haven't been there for a while, but a couple of summers ago I was, and I thought that was really cool. Here's the thing. I know how tall this guy is, so could I figure out the height of this eyeball? What about the circumference or diameter? Could I figure out the volume of the eyeball? How about just the pupil? Could I do that? How about the iris? I mean, there's so much math you can do in this. Digital camera. Just took a shot as I was actually driving past on a bus, so I came back to get the picture. Here's another one. What can you do with this? Every city has a Lego store. Go stand in front of the Lego store, take your picture, and do all kinds of math and science with that. How wide is the Lego? How tall is the Lego? I know how tall I am. How big would I need to be in order for that Lego to be the same size a regular 4x2 Lego is now? Bring in a little 4x2 Lego. You can get it at any garage sale. Bring in a little tiny Lego and say, what's the proportion between me and this Lego? What's the proportion between me and this Lego? How big would I need to be for this? How big would Gulliver need to be with this? Love it. How big are the letters? How much area do these circles take up? What's the area of the rectangle here? I mean, there's so much you can do with this. And this is a house in my neighborhood, and look at all these beautiful triangles. I always encourage you to look up and look down because there is so much cool stuff, shapes and figures and all kinds of stuff that you could do. You might say that, is that obtuse? Is it acute? Is it a right angle? How do you know? Can you measure it? What can you figure out with? Now, if you have upper grades, Casio has a dynamite new calculator, the Prism, where you could actually import this into the emulator software, and you can actually plot these points and figure out exactly what it is. Of course, you can always print the picture off and use a protractor too, but my gosh, the learning just doesn't stop with this kind of thing. So I encourage you to take out that digital camera, take out your cell phone, take pictures, put them in your kids' hands, and just ask them, where's the math in this? Is there any science in this? I wonder what the area of this door is. I just wonder. I wonder what the ratio of this height is to this height. I wonder if these are similar triangles. And just start talking, start the conversation, and see where your kids take it, because they will. They'll take it somewhere. Ladies and gentlemen, that's all I have for today. It's been just about an hour. I'm just a little shy of an hour, so if you have questions, we have a couple minutes, but I have to tell you it's been absolutely delightful. Hopefully you have some things to do tomorrow and the next day and next week at school so that you can end your year on a very high note. Thank you. Thank you very much for your time. I appreciate it.
Well, thank you very much, Nancy. It's been a pleasure. I've enjoyed your presentation. In fact, I'm already plotting to employ some of those with my own kids. Trick them into doing math as well.
I know. You know what? And I'm telling you, they won't stop. They won't want to stop. So so just play. You know, just make math fun. Thank you very much. Any questions?
I haven't seen any questions. I do want to really briefly, let's see, really briefly, I just want to, whoops, that's what happens. I just wanted to make sure that I share with anybody who's interested. You had mentioned the Prism at the end. We do have this online training. If you go to casioeducation.com/educators, we have online training of a couple sorts. There's Prism, there's a ClassPad as well. So, you know, take a look at that if you have any curiosity. So
yeah, and if you haven't seen the Prism yet, you are in for a treat. So give yourself a little gift of an hour or two and just peruse. You will be absolutely just blown away and delighted.
Well, thank you again, Nancy, and thank you to all those who joined us this evening.
Thank you. Good night.